All right, so those of you who started, I saw that you factored the numerator here. What were the numbers that multiply to -8 and add to -2? What'd you get, Estrella? +2, -4. Anybody else find those numbers? Yeah? Okay. So we had x plus 2 times x minus 4. And then in the denominator, we had x minus 4. And then once you have it factored, because multiplication and division undo each other, you can cancel these factors and end with x plus 2. All right, now, some of you are pretty good at algebra 2. You can do a problem like this, but then when it comes back to algebra 1, that's where you might struggle. Algebra 1 would be solving a linear equation. So sometimes we get to this point, and then some of you feel stuck. So we have to review this concept as well. First thing you want to do is get your x's on one side. So to get x's on one side, you have to get rid of one of them. So you get to choose, would you prefer to subtract the 3x or subtract the 7x? Okay. If you chose to subtract the 7x, you also may have gotten the right answer. It's not a problem. So those cancel, and I have 5 equals 4x minus 2. And then after you get the x on one side, you want to isolate the x, which means get rid of everything except for x on that side. So isolate x. When we undo operations, we use backwards PEMDAS, SAMDEP, or SADMEP. All right, so we undo the addition and subtraction first. So 7 equals 4x, and then divide by 4. And so you get the fraction 7/4. That's an acceptable answer. Or you could make it the decimal, 1.75. Either one's fine. All right, what questions do you have on the warm-up? All right, so today what we're going to be doing that's new is solving a rational equation. So on the first day of this unit, we multiplied and divided rational expressions, and then the second day we added and subtracted rational expressions. But there was never an equal sign. We never found like x equals a number. So today we're solving equations, and we're going to find a number that x equals. This is the third and last day of our unit. So Wednesday we'll be reviewing, and then Friday we'll be quizzing. So I want you thinking ahead about that because I don't have a lot of availability at the end of the week, but I am after school today, tomorrow, and Wednesday. So if you think you'd like a little extra help before your quiz, make a plan. All right. To solve a rational equation, you want to multiply each term on both sides by the lowest common denominator of the terms. And remember that the terms are separated by the plus, the minus, and the equal sign. So I have like 3 terms on my first problem. Cancel the factors within each term. This will eliminate your denominators, and then you'll be able to simplify and solve the polynomial equation. Rational equations, just like the logarithmic equations, could have extraneous solutions. All right, so remember that the input to the logarithm was not allowed to be 0 or a negative number. Rational equations are not so restrictive. They just can't have a 0 in the denominator. Like, have you ever tried to divide by 0 on your calculator? It won't let you, right? So you can't have 0, good morning, in the denominator. All right. I actually do the first step of my rational equation a little bit differently than this. This does work, but what I like to do instead is to just get that common denominator and then cancel my common denominators. So to get a common denominator here, I have an x and I have a 2. So you remember you multiply each fraction by what it's missing. So this one has the x, it's missing the 2. This one has the 2, it's missing the x. And then this one also has the x and it's missing the 2. So that should look a little bit familiar because that's kind of like what we did last class when we did common denominator. And so I have 8 over 2x plus 5x over 2x equals negative 22 over 2x. Sorry, let me make that a little bit larger for you. Does anybody need me to adjust the lighting or just zoom in more? Okay. All right, now at this point, because our denominators are the same, some people just cancel them out. If you would like to know the mechanics of why that works, though, it's just because we're multiplying both sides by 2x. So if I were to multiply this side by 2x and this side by 2x, right, that would cancel out these denominators, and this would cancel out these denominators. And so I have this simple equation now, 8 plus 5x equals negative 22. And then we already have the x's on one side, so we just have to isolate the x. So first we're going to undo addition and subtract this 8. And then we'll undo multiplication, and we will divide by the 5 to get the x by itself. All right, just a quick check to make sure that negative 6 doesn't make my denominator 0. If I put negative 6 in for the x, it doesn't make the denominator 0, so we're good. It checks out. All right, in the next one, we only have one denominator. The denominator is x. And so we're going to multiply the terms that don't have that denominator by x over x. So this one already has an x. This one is going to be times x over x. And this one is times x over x. So I have 3 over x plus x times x is x squared over x equals 4x over x. We get to something like this, and a lot of people are like, well, I could cancel out the x. Yes, you could cancel out the x, but why would you do that? You just put it there, right? The reason you put it there is because you wanted them all to have the denominator x. Now that they do all have the denominator of x, you can multiply both sides by x to cancel them out. So see, that x will cancel out those, that x cancels out those, and so I have 3 plus x squared equals 4x. All right, this is not a linear equation. What kind of equation is it? It's quadratic. Good job. Quadratic equations we solve a little bit differently because you can't just isolate the x because you've got an x squared term and you have a 4x term. So for quadratic equations, you want to get them in standard form, which means first the x squared, then the x, then the constant, and then equals 0. So you want to get in standard form because it's quadratic. Get it in standard form. All right, so I already have the x squared and the 3 on this side, so what I'm going to do is subtract the 4x. That will move it to the left side, and I'll get 0 on the right side. When I write out these 3 terms, I'm going to put them in order from the biggest exponent down to the smallest. So I have x squared, then the minus 4x, and then the plus 3, and then equals 0. And what will be our strategy for solving this? I heard a factor. Who was that? Good job. All right, so we're going to factor. So we're going to find the numbers that multiply to positive 3 and add to negative 4. Tell your partners if you know what those are. Multiply to positive 3 and add to negative 4. Did you guys get negative 3 and negative 1? Good. And then we have x minus 3 equals 0. X minus 1 equals 0. Solve them. All right, neither of those numbers makes the denominator 0, so we have two solutions. All right, so I'm skipping to this one just because it looks a little bit different because it only has the two fractions. In this problem, the denominators are x plus 3 and 4. So the first problem, it's missing the denominator of 4. So it's going to be times 4 over 4. The second one is missing the x plus 3. So it will be times x plus 3. So that gives me 28 over 4 times x plus 3 equals, I'm going to distribute this, x squared plus 3x over 4 times x plus 3. So each denominator gets what it's missing. The first denominator was missing the 4. The second denominator was missing the x plus 3. Then, technically what you're doing is you're multiplying both sides by 4 times x plus 3, and that's going to cancel your denominators. But sometimes that gets to be a lot to write, so you can just cancel your denominators when you get to this point with the understanding that what you're doing is multiplying by 4 times x plus 3. And so then I'm left with 28 equals x squared plus 3x. Is this linear or quadratic? It is quadratic, good. So we're going to get it in standard form. We're going to subtract the 28 on both sides. And then take a moment to factor that. So I'm just going to move over here. And compare your factors with your neighbor, see if they get the same thing as you. Okay, so the numbers that multiply to negative 28 and add to 3, you should have a plus 7 and a minus 4. We're good with that? And then you set your factors equal to 0. So x minus 4 equals 0. X plus 7 equals 0. X equals 4. And x equals negative 7. The denominator that has x in it is x plus 3. So if I substitute back in the 4, 4 plus 3 is not 0. Negative 7 plus 3 is not 0. So both of the answers work fine. We keep them both. Okay? All right, so I need you to take a moment and try problems 1 and problem 3. Here's one little hint when you're starting up problem 1. That minus 6, that minus actually belongs to the 6, but we lose track of it, so you might want to make the minus into plus negative, just so that you remember that the 6 has the minus on it. And then remember to multiply the first fraction by what it's missing from the second denominator, and then multiply the second fraction by what it's missing in the first denominator. Let's quiet down and see how you did. First one, this denominator has x plus 2, but it's missing x minus 1. So I'm going to multiply this fraction by x minus 1 over x minus 1. This fraction has x minus 1. It's missing x plus 2. And the other side is 0, and that 0 is actually missing both of them. So technically, I'm multiplying that 0 times x minus 1, x plus 2. But luckily, 0 times anything is what? 0. So even though I have to also multiply the 0 times these factors, all it gives me is 0, so no problems. So here, I'm going to just distribute only on the top. There's no point in distributing the bottom because it's about to go. All right, so I have 3x minus 3 plus negative 6x minus 12 equals 0. And Austin points out, since we know that these denominators are all the same now, we can just get rid of them. We don't have to write them out and then get rid of them, okay? So I multiplied the first fraction by what it was missing, and then I distributed the 3. Multiplied the second fraction by what it was missing and distributed the negative 6. And then I multiplied the 0 times both of them, but 0 times anything is still 0. We do know that in the next step our denominators are going to cancel, so we can just get rid of them right here. And then I'm going to combine my like terms. So notice the 3x and the minus 6x are on the same side of the equation. So you just combine them, and I get negative 3x. Negative 3 and negative 12 are on the same side of the equation, so I combine those to get negative 15. And now to get x by itself, first I'm going to undo the subtraction by adding 15. And then I'm going to divide by negative 3, and I get x equals negative 5. And you need to check and see if that makes any of your denominators 0. So negative 5 plus 2, that's not 0. Negative 5 minus 1, that's also not 0, so we're good. We are going to do the last problem, so make sure you're good on that one so I can move the paper. All right, let's go down to 3. In problem 3, notice x minus 2 is already here and here, so there's just one more place it needs to be, which is right here. So I'm going to bring this down. I don't really have space to write in here, so I'm going to bring down 5x over x minus 2 equals 7. The 7 needs the x minus 2, so it's going to go in the numerator and the denominator. And then plus 10 over x minus 2. Okay, once you have all the denominators the same, you technically are going to be multiplying by that lowest common denominator on both sides to eliminate it. If I were to do x minus 2 times this, it would cancel out these. And on this side, if I do x minus 2 times this, it cancels out these. And so then I'm going to distribute. 5x equals 7x minus 14 plus 10. These two are like terms, so I can combine those. And now I have x's on both sides, so I've got to get the x's to one side of the equation, so I can choose. Do you guys want to subtract 5x or 7x? I didn't hear. What do you want? You want to subtract the 7x? Okay. So if I subtract the 7x, I get negative 2x equals negative 4. These cancel. And then I have the x here, I have to divide by the negative 2, because negative 2x means negative 2 times x. So you undo that by dividing, and I get x equals 2. All right, what's the problem with that answer? I did all the steps right, but there's a problem with my answer. What is it? All right, Eddie says it makes the denominator 0. Let's check. 2 minus 2, is that 0? Yes. So this is an extraneous solution. I'm going to write a lot of words here because this is the first time we've had one. When you're doing a test, you'll be able to just say extraneous, therefore no solution. That's fine, okay? But I want you to have all the words so you understand what we're doing here, okay? When I substitute two for x in the original equation, it makes the denominator 0. So this is extraneous. Therefore, no solution. So no solution is what we box up.